All right, welcome everybody to the homework help session with Kaylee here today. And I have the first question that she has brought for us listed on the screen here. And it's about finding rational zeros. And it's about finding rational zeros when you're given nothing, about the function that you have here. So I'm just going to show that this is a function. All right, so this involves the whole process of P over Q, which I just taught that particular lecture yesterday. That's lecture 2.5. So if after watching this video this is still just foreign looking to you, you can find the more information about that process in lecture video 2.5. Which I've had no problem lately converting all of the lectures over to MP4 format. So you have the choice of either watching it through the Blackboard Collaborate player, or you can click on MP4 if your computer won't play the Blackboard Collaborate version of it. And you can actually download the MP4 version to your own computer if you want to. Okay, let's get going with this. The first thing we want to do is determine how many possible positive and negative rational zeros we're going to have. That has to do with the Descartes rule of signs, and it's however many sign changes show up in the function and in f of negative x that determine what the possible amount of positive and negative zeros you can have will be. So I'm just going to go through and I'm going to mark the sign changes that I see. So from the first term to the second term, no sign change. They're both positive. There's a sign change here and another sign change here. So we will have either 2 or 0 positive real zeros. Now we need to do f of negative x to determine about the negative real zeros. So I'm just going to plug in negative x wherever I see x into the function. And simplify. And now note the sign changes with that. So I have a sign change here, here. So I'll either have 2 or 0 positive, negative real zeros.
Would 5 not change to a negative number?
The very first term?
Yes, because it's...
Okay, if I raise negative x to the 4th power...
Oh, yes, I see.
Yeah, that's negative times a negative times a negative times a negative, which is a 5. But I'm glad to know that you're looking at this and thinking about it and not just watching me do it. Very good. Okay, so we're either going to have 2 or none of each of the either positive or negative zeros. So what this does is it kind of cuts our synthetic division work that we're going to have to do once we determine P over Q. Okay, so let's go ahead and move on to P over Q. So this is going to narrow down our playing field here from infinitely many possibilities to whatever we get with for the P over Q value. So the P value are the factors of A sub 0, which is 10 in this case, and Q are the factors of A sub n, which is 5 in this case. So for the factors of 10, I have positive negative 1, positive negative 2, positive negative 5, positive negative 10. And for 5, I have positive negative 1 and positive negative 5. So, since I am dividing each of the factors in the top by a factor of 1 or negative 1, that's just going to leave all of those factors in the top as possibilities. So far, I have the possibilities of positive negative 1, positive negative 2, positive negative 5, positive negative 10. And now I have to come back and divide each of those by 5. Luckily, 5 divided by 5 is 1, and 10 divided by 5 is 2. So those are already taken care of. But I do have to take into consideration positive and negative 1/5 and positive negative 2/5. Hopefully we won't have to make it to those. All right.
That's where it lost me.
I'm sorry?
That's where it lost me, was the dividing part for the...
Okay, does that make sense, though, with what I have out here for all of our possibilities? Okay, good, good. All right, well, we'll go ahead and begin the synthetic division process. And what you have to remember is that you have to try a factor, you have to try, a factor until it fails, because it could be in there more than once. That's where the whole idea of multiplicity of the factors shows up. So the first one we're going to try is a C value of 1. Now let me remind you, this would correspond to a factor of x minus 1, because all of these factors are in the form of x minus c. All right, so let's get back to the synthetic division process. So 5, 9, negative 17, negative 2, and 10. All right, combine down, multiply, combine down, multiply, combine down, multiply, combine down, multiply, combine down. We have a remainder, which means not a factor. So, fails. Next up. So the next one we're going to try is negative 1. And that would correspond to a factor of x plus 1. You good so far, Kaylee?
Yes.
Okay. 5, 9, negative 17, negative 2, and 10. Combine down, multiply, combine down, multiply, combine down, multiply, combine down, multiply, combine down, fails. All right, moving on to positive 2. Let me move my marker board down here so I can write to the bottom of the page. All right, 5, 9, negative 17, negative 2, and 10. This is for a factor of x minus 2. So combine down, multiply, combine down, multiply. My brain just went away. 21, I think. Yes. Multiply, combine down, multiply, and combine down, and fail. This is the tedious part of the process, if you can. Yeah. I'm just thankful that we don't have infinitely many possibilities.
Yeah.
Okay, so now we're going to try negative 2. And we have 5, 9, negative 17, negative 2, and 10. Okay, combine down, multiply. By the way, this is for a factor of
X plus 2.
X plus 2. Excellent. Thank you, Kaylee. Okay, combine down, multiply, combine down. Getting kind of big here. Multiply, doesn't look like we're going to make it. And negative 56, negative 46 fails. Woo. Okay, now we'll try 5. Maybe we'll hit one here soon. 5, 9, negative 17, negative 2, and 10. So 5, 25. Whoa, 34. Can't do that in my head. 34 times 5. I should be able to, but 170. I doubt that's going to zero out for us. 153. Yeah, this is just getting bigger and bigger and bigger. There's no way that's going to zero out. We'll just stop there.
Yeah, I kind of gave up after 2 when I tried it in the homework.
All right, let's try negative 5. I hope we don't get all the way through this and it was none of any of them. That would be frustrating. Negative 2 and 10. Okay, negative 25, so that's negative 16. Come in. I've got a student online right now. Okay, I'll probably be done here in about 15 or 20 minutes. Okay, I'll be back in my office at 2. I have a little break between 12 and 1 if you want to stop by. All right, I'll see you then, Sean. Sorry about that.
That's okay.
Okay, 5 times 16 is 80. Let's see, it's getting big again. 80 minus 17 is 63. 5 times 63, that's going to be a big negative number. Yeah, that's not going to, won't make it.
I think maybe the fractions would be
No. Have you already tried 10 and negative 10?
No, I haven't.
All right, let's give those a try before we move to the fractions. 5, 9, negative 17, negative 2, and 10. Okay, so 5, 15, 24, getting big already, 240. Let's see, nah, because it's got to multiply by 10. Let's see, 240 minus 17 is 223 times 10. Yeah, that failed. Jeez. Thank you, my math lab, for giving such a sweet problem here. 5, 9, negative 17, negative 2, and 10. This is a good one to look at. It shows the importance of persistence. Negative 41, 410. Let's see. Yeah, that's not going to work out either. All right, let's move to the fractions. Okay, we'll try 1/5. Five, 9, negative 17, negative 2, and 10. Okay, so bring down. 1/5 of 5 is 1. 9 plus 1 is 10. 1/5 of 10 is 2. negative 15. 1/5 of negative 15 is negative 3. Negative 2 and negative 3 is negative 5. 1/5 of negative 5 is negative 1, and it still fails. Maybe the negative will make it happen for us. All right, we're going to run out of room on this screen with this one. Negative 1/5. Well, here's something to think about. If negative 1/5 shows up, we know it's got to be in there twice, because it had to either be in there 2 times or no times. Does that make sense from what we figured out with Descartes' rule of signs?
Right. So if it's a negative, then it has to be twice.
Yeah, it's going to have to be in there 2 times. So 5, 9, negative 17, negative 2, and 10. Negative 1/5 of 5 is negative 1. This isn't great, because now we're getting negative 8/5. Let's see what 17 times 5 is. I never learned my 17 times tables. Imagine that. Okay, so that's 85 and 8. That doesn't divide evenly by 9. I'm sorry, by 5. So that would be 93, negative 93/5. And if I multiply that, that's a positive 93/25. Let's see, so negative 50, and 93 minus 50. So this leaves us with a positive 43/25.
Where did you get 50 from?
I had to turn that into an improper fraction. So up here at the top, if I have 2 over 1, and I'm trying to get 25 on the bottom, I've got to multiply 25 over 25. Okay, so this would be negative 43/1/25, and that's not going to come out to 0 there. Oh. This problem sucks.
That's exactly what I was thinking.
And watch it be none. After we do all this work, it's like, there aren't any of them.
I didn't know that was an option for...
It's an option because it could have no rational zero.
Oh.
For example, like, let me erase a little bit of the space up here. Say you had, where'd my pen go? There it is. Say you have a graph of some polynomial function, and it just kind of does this. And it never crosses the x-axis, there are no real zeros there. Because we know zeros are where these things cross the x-axis. So there's the possibility, or if it was pointing down and just kind of did its thing and never crossed the x-axis, you're not going to have any real zeros.
So really, you could just put it in your calculator and graph it and look at that.
Yeah, that's actually a pretty dang good idea, since we've been through all this, to see if this thing even has any real zeros. I think you understand the process pretty well at this point. Let's see, I'm putting it into my graphing calculator. 4x to the 4th plus 9x cubed minus 17x squared minus 2x plus 10. Okay, so
Mine looks like it does.
yeah, mine does too. Let's see where that's crossing. It doesn't look like either 2/5 or. Let me zoom in on this. See what values we have here. They might not be rational. They might be irrational numbers. That's why when you gave me the problem, I made sure that it said find the rational real zeros. Okay, so I'm going to calculate these places where it crosses the x-axis. Okay. I'm willing to bet we're not going to get a real zero here. I'm sorry, a rational zero. Yeah, it's negative 0.740774. That's not a rational number. And I'm willing to bet the other one isn't either because it's not anywhere near any of our possibilities. Yep, there are no rational zeros here. Do you want me to show you how I just calculated those zeros on my calculator?
Yes, please.
Okay, so let me go back. Zoom 6 takes you to the standard window, which is -10 to 10, -10 to 10. Can you see that okay, Kaylee?
Yes, that's what mine looks like right now.
Okay, very good. What I do next, I want to zoom in. Actually, I don't really need to zoom in. I can calculate those exact places where it's crossing the x-axis by doing seconds. So the second key is right here, second, and trace, which is up there in your functions, which gives you your calculate menu. Second and trace. Do you see your calculate menu now?
Yes.
So let me show the screen mine. And you want to choose number 2, which is calculate a zero.
Okay.
Okay, so when you look at your screen, it should say left bound. That's asking for a left boundary to the point you're trying to calculate. So if you move your cursor, it'll bring a little blinking cursor onto the screen. Do you see that?
Yeah, I think I do.
Okay. So what you want to do, you want to move the cursor so that it's to the left plane of the point you're trying to calculate on the function. So I'm going to show you where I put mine. Let's see. You see my little cursor blinking at right there on the function? The point I'm trying to calculate is here. So that is to the left of that point on the function. Once you get there, hit enter, and it will give you a little arrow. You can see the arrow at the top there pointing towards the point I'm trying to calculate. And now it's asking for a right boundary, so arrow right, don't cross over the y-axis though. So now I've put my cursor up there, and it's blinking, but it's to the right plane. It's in the right plane of the point I'm trying to calculate. Does that make sense?
Yes.
Okay. Hit enter. And now it gives you another arrow, and they're both pointing in towards the point you're trying to calculate. And it wants you to guess. Don't worry about guessing. Just hit enter. And you can see it gives me the y value down there, I'm sorry, the x value of negative 0.7407741, blah, 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 blah.
Okay.
That is not a rational number. And the other one's not going to be rational either, because if you look at our choices here, none of those are anywhere near that other 0. So there's no way that that's a rational 0.
Okay.
So what I have pictured at the top right there when I was talking about crossing the x-axis, these have imaginary zeros because it doesn't cross the x-axis. So you can cross the x-axis and not be rational.
Okay.
So hopefully that, this is, believe it or not, this is a good one to look at because it brought out a lot of things that you really need to understand about these functions. But I would not like to do it again. I'm scared to ask if you brought another question with you, Kay.
I'm trying to look and see because I was pulling up the question in my homework to make sure I wrote it down right.
Okay.
Oh,
excuse me. So I've also just shown you a way to cheat on that problem too with your graphing calculator.
Yeah,
but a lot of times they'll ask you, they'll ask you for like the P over Q value so that you have to know what you're doing, that type of thing. And you've got some Descartes rule of signs problems too. So. Oh, I promise it's not the company, it's me.
For some reason now it won't let me bring up the homework tab in my math lab.
Uh-oh. It may be because you're in Collaborate here, and a lot of times when you have a program like this running in the background, my math lab doesn't like for you to log in and all that stuff. Maybe. It could be that.
The other two problems I was having trouble with were, they were at the very end of section 2.4.
Okay.
And after I found the rational, to make sure, I'm sorry, after I used synthetic division, it was asking me for a solution set.
Okay, so that's asking you to solve an equation and give the solution set. So
I actually have one of the problems written down if you want me to write it down.
Let me clear our page off. Because it's the same type of idea. You're going to go through the same process. It's just solutions are x-intercepts. You're solving for x in the equation, or you're using the zero product property to solve for x to find your x-intercept. So it's the same type of process, just the difference is having something in the form of 0 equals some polynomial over here. That would be an equation that you would solve, or f of x equals some polynomial. This one is one that you graph, so you're finding x-intercepts, which we call zeros. This one is going to have a variable in it. So you're going to solve and get the solutions for x, but you're doing it the same way either way. So we'll work through that when I've got about 20 minutes before I have to be in class. So we'll have to boogie through this one.
Okay. Like I said, I understand the synthetic division part perfectly. I get that completely.
Okay.
It's just the thing that caught me off guard was the brackets, and it was asking me for the solution set, and I was like,
okay.
Well, I don't know.
Okay. Okay, so what's the problem?
Okay, it's x cubed minus 13x squared plus 47x minus 35. And
it says equals 0, I assume?
Yes,
okay.
And then given is the 0 of f of x.
The reason it says the solution set is because there's more than one solution here, so it's going to give you something that looks like this.
Yes.
And you just put your solutions in there separated by commas. It's just because there's more than one solution to the equation. Okay, so let's go ahead and get moving on this, and hopefully I'll have time to finish it off. Okay, so P over Q, we have positive negative 1, positive negative 5, positive negative 7, positive negative 35. Over positive negative 1, thank goodness, which means the only possibilities are these. We have 1, 2, 3 sign changes with f of x, so we're either going to have 3 or 1 positive solutions. And if we do f of negative x, we get negative x cubed minus 13 times x squared, plus 40 negative x squared. 47 times negative x minus 35, and that is negative x cubed, negative 13x squared, negative 47x minus 35. So we end up with, let's see, no negatives. I have no sign changes here. Do you see that?
Yes.
Okay, so 0 negative. We can go ahead and come up to our P over Q and say, nope, none of them are going to be negative. Make sense?
Yes.
Okay. Synthetic division. So 1. We have 1, negative 13, 47, negative 35. Bring down, multiply, bring down, multiply. 35, 35, bingo. Oh, that feels so satisfying after the last one. Okay, so here's what we have found. We have found so far that 1 is in the solution set.
So you would just write 1 instead of x minus 1.
Yeah, that is the factor that it comes from. So if you were factoring that polynomial out, you would then, okay, so what this means is that 0 equals x minus 1, which is the factor you just found, times x squared minus 12x plus 35, which is the leftover right there. So if you were working through this in the regular way, you'd factor it, and then you'd set up the 0 product property to solve for x. So x minus 1 equals 0. X squared minus 12x plus 35 equals 0. So here, x is 1.
Right.
And actually, I can factor this other thing in my head. I don't need to use synthetic division. This is the same thing as x minus 5 times x minus 7 equals 0. So x minus 5 equals 0, x minus 7 equals 0, so x is 5, x is 7. 1, 5, and 7 are your solutions.
I understand.
Yay! I love to hear that statement. That makes my heart sing. And notice we got no negative solutions there because we knew to expect none by using Descartes' rule of signs.
Right.
I'm going to have to leave you. I'm sorry I can't do the last problem with you, but I've got to get to class.
That's okay. My last problem was really similar to that one, and that just answered my question pretty much.
Very good. Well, Kaylee, thank you so much for meeting with me this morning. I'm sure that this will be majorly helpful to your classmates to watch this video, especially with that first one we worked through, because like I said, a lot got revealed about, you know, just a ton of stuff about finding these zeros like that. So I will not be able to post it until I get back from class, which will be around 12 o'clock, but it should be in the news feed shortly after.
Okay.
All right. Have a wonderful day, and thanks again, Kaylee.
You too. Thank you.
Bye-bye.
Bye.